Hello everyone. I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam and we are focusing on ISS 2026. So we have completed the topic, one of the major topics, econometrics in our previous lectures, and we have started with sampling techniques, and we are currently doing systematic sampling. In the last lecture, we did variants of systematic random sampling, two forms of variances of systematic random sampling, and comparison of systematic random sampling with simple random sampling without replacement. Today, we'll do another comparison of systematic random sampling with stratified random sampling. So let us begin. Comparison between stratified and systematic sampling. Before comparison, let us first derive systematic stratified random sampling in the form of first systematic random sampling. So we know that the size of the population is equals to capital N. Systematic random sampling, when we did the layout, it was like the sample is given like 1, 2, I, K. And here the rows were mentioned as 1, 2 up till N. So these were Y1, Y2, YI, YK, and it was YK plus 1, YK plus 2, YK plus I, Y2K, Y n minus 1 into K plus 1, Y n minus 2, n minus 1 into K plus 2, Y n minus 1 into K plus I, Y n K. This was our layout of stratified systematic random sampling. So these are the samples. So in stratified random sampling, let us take these as stratas. These rows, row 1 as strata 1, row 2 as strata 2, and row n as strata n. Similarly, row n as strata n. So let us take these as stratas, and each having the stratum size as k, because every every of them has size k. And we will take one sample from each stratum and then form a small sample. So let us consider a systematic population of size is equals to capital N, or it can also be written as small n into k, where the rows are represented as stratas of size small k, and we draw sample units from each stratum. Sample unit, it should be, we draw one sample unit from each stratum. This is the overview of how stratified random sampling can be taken from systematic random sampling. So we know that uh, mean of stratified random sampling is y bar st. Y bar st is nothing but 1 upon n summation j goes from 1 to n y j bar. This is the mean of stratified random sampling of size of strata small n. These are the this is the formula for that. Now here, if we find this is an unbiased, which is an unbiased estimator of population mean. Capital Y bar. This we had proved in systematic random sampling that Y bar ST is nothing but the unbiased estimator of population mean. Okay, so now we will calculate variance of Y bar ST. Variance of Y bar ST is nothing but variance of 1 upon n summation j goes from 1 to n. Okay, let us take this in the form of in the general form, not for this one only. So it will be 1 upon capital N summation j goes from 1 to capital N nj into y bar j. Let us take it here as like this. So we know that capital N is nothing but 1 upon nk, and this is nj is nothing but 1 upon k. Sorry, nj is nothing but the size of each strata k and y bar j. Your k and k gets cancelled and we are left with 1 upon n summation j goes from 1 to n y bar j. This is the derivation for it. You can write it in general form or you can directly write it like this. So it is nothing but y bar j. Now this can be written as 1 upon n square. When n comes out of the variance, it will be squared. Summation j goes from 1 to n variance of y bar j. Now y bar variance of y bar j. If we express in terms of, we know that variance of y bar I, y bar or simple y bar in simple random sampling is nothing but capital N minus small n upon capital N into small n s square. So in this term, capital N is population size and small n is the size of the sample size. So population size here, if we talk about variance of y bar j, here population size is nothing but capital K, size of each stratum is capital K, minus size of each sample is 1. We take one sampling unit from each stratum, it is 1. And similarly we'll multiply by K and 1 in the denominator and s square, because we are talking about j, so it is s square j. Putting this value in the above equation, it is nothing but 1 upon n square summation j goes from 1 to n. This will be k minus 1 upon k into s j square, which can also be written as k minus 1 upon n square k summation j goes from 1 to n s j square. Now we know that sj square is nothing but 1 upon k minus 1 summation j goes from 1 to n y j minus y bar whole square. This is sj square, and sw square is nothing but 1 upon n summation I goes from 1 to k summation j goes from 1 to n yij minus y bar whole square. This is sw square. So substituting the value of sw square and sj square in the above equation, this can also be written as sw square into n summation is equals to summation I goes from 1 to k summation j goes from 1 to n yij minus y bar whole square. So putting it in this equation, variance of y bar st, we will get variance of y bar st. We are calculating this in terms of systematic random sampling so that we can compare both of them. So variance of y bar st is nothing but n into k minus 1 upon n square k into sw square. Here n square and n gets cancelled and we are left with k minus 1 upon nk can be written as capital N sw square, where this sj square is the mean sum of squares of units in jth stratum, and this sw square is mean sum of squares of each sampling unit within stratum. This is within mean sum of square, and this is of any particular stratum, jth stratum, that's mean sum of square. So this is our formula for variance of y bar st, right? And this can also be written as, if we multiply by small n on above and below, this is nk minus n upon n n sw square. Now nk is nothing but capital N, so we can write it as capital N minus n into sw square. This variance can also be written like this. So moving on to another part where we actually compare these two variances. So first of all, variance of y bar systematic. We all know that variance of y bar systematic is nothing but n minus small n upon capital N minus into n s square 1 plus rho n minus 1. This is the variance. Its derivation we have done in previous one of the previous lectures, so you can go back and watch that if you have confusion in this. This can also be written as sw square because it was also within sample. So now we will calculate relative efficiency of variance of y bar systematic with respect to variance of y bar stratified. Now, the one for whom we are calculating. Suppose we are calculating for systematic here, that will come always come in the denominator. So, stratified will come in the numerator, y bar stratified, and systematic will come in the denominator, y bar systematic. So variance of y bar stratified, as we had calculated before, it is nothing but n minus n upon capital N into small n s s w square. And this variance of y bar systematic will be n minus n upon capital N into small n s w square 1 plus rho n minus 1. So this whole term s square, capital N minus n and nn gets cancelled, and we are left with variance of y bar stratified upon variance of y bar systematic is equals to 1 upon 1 plus rho into n minus 1. Now all of it depends on the value of rho. If rho is greater than 0, suppose we take it as variance of y bar st into 1 plus rho n minus 1 is equals to variance of y bar systematic. So if rho is greater than 0, so this whole term is this whole one is, if rho is greater than 0, so this whole will be greater than 0. So variance of y bar st is greater than equal to variance of y bar systematic, right? And from here we can say that efficiency of systematic sampling is greater than efficiency of stratified sampling. So we can write, if rho is greater than 0, rho is less than 0, and rho is equals to 0. If this happens, so when it is greater than, variance of y bar systematic is more efficient. When variance of y bar stratified. And if this happens in the reverse form, suppose it is rho is less than 0. So this also reverses, this sign also reverses. Here, from here we can say that variance of stratified sampling is more efficient than variance of systematic sampling. So we'll write it here. Variance of systematic is less efficient, because we are talking about systematic, so we'll talk with respect to that only. Less efficient than variance of stratified. And now if what happens if rho is equals to 0? Rho is equals to 0, so this whole term will become equals to 0, and we are only left with 1, and hence 1 multiplied by variance is only variance, and equal to sign will come in between. So variance of y bar systematic is equally efficient to variance of y bar stratified. Okay, we can also do this in the form of so in the form of subtraction. Variance of y bar systematic minus variance of y bar stratified. This can be written as n minus n upon n s w square 1 plus rho n minus 1 minus n minus n upon n s w square. So taking in common n minus n upon n sw square, we are left with 1 plus rho n minus 1 minus 1. This minus 1 and plus 1 gets cancelled, and we are left with the same term n minus n upon n sw square into rho n minus 1. Now here also everything depends upon rho. If rho is greater than 0, then again variance of y bar systematic is more efficient than variance of y bar stratified. If rho is less than 0, then variance of y bar systematic is less efficient than variance of y bar stratified. And if rho is equals to 0, then variance of y bar systematic is equally efficient to variance of y bar stratified. You can either prove it by differencing, or you can prove it with relative efficiency method. Both of them are correct, and this has been asked many number of times in the PYQs. This and simple random sampling, and the efficiency among the three of them: simple random sampling without replacement, stratified, and systematic sampling. That we'll do by a linear method tomorrow, in tomorrow's lecture. And I hope you got what we have done today in the class. Keep on revising your notes, keep on making the notes and watching the lecture videos and revising your notes. Be consistent with your work, only then you will be able to succeed in this exam. This exam needs consistency, so keep on working hard on it. If you have any doubts regarding the topic, then you can ask on our WhatsApp channel, and in the comments below we'll answer all the relevant doubts. Thank you.